Multiplication property of exponents. Welcome to an assignment that I think is not only useful in and among itself, but will help you with tests that you have to take either this year or later on in high school, whether that be the PSAT, the SAT, the ACT, the college entrance exams like from CCC. You will have a lot of opportunities to try some of the methods that I will teach you in this assignment and make use of them. So let's dive right in and take a look at our first couple of problems. Now, I think about complaining students in my head who tell me things, especially at the beginning when you write me a reflection of your thoughts on history of math, thoughts of your own life, you sort of an introduction letter. I call it a mathography. And so many say something like, I actually used to really like math. I liked it a lot. And then letters started mixing with numbers, and that's when I was just done. And I've been done ever since. Well, these first two problems are definitely letters and numbers directly mixed. And so if you're one of those out there that are in that camp, I feel for you. And yet, I'm going to be here right beside you, helping you every step of the way. Y ninth, Y tenth. They're stuck together, which means they have that rabbit property I always talk about. They're multiplying. Now, you might not know what in the heck to do with a y ninth times y to the 10th. And here comes the test-taking strategies. I would always do this on tests. I had test anxiety like many people. I'd log on, or I'd have a paper and pencil, and as I would be doing a test, often I would be forgetting things that I knew, and yet I just couldn't think of them. And so I had to figure out tricks that I can use when I couldn't consult my notes and I couldn't talk to a teacher, to figure out how to do something in that moment. And here's what I always did. So if I forgot what y to the 9th times y to the 10th did, I knew there was some trick that I could do something with these exponent numbers. I would pick a small number, say 2. And I would say, all right, 2 to the 9th times 2 to the 10th. What is that? And then can I figure out the pattern by guessing and checking? Like maybe I multiply them. Maybe that's 2 to the 9 times 10 or 2 to the 90th. And then I would see, oh my gosh, those numbers don't get close to matching. Can't be that. What else can you do with those numbers? Well, I could add them, and that would be 2 to the 19th. Oh my gosh. Then I would see them match, and I would take a big breath, pat myself on the back, and I'd go, all right, Dylan, you did it. So now I know that y to the 9th and y to the 10th is y to the 19th. See what I did there? You just substitute a number in for the letter, and that helps you figure out the property. The same thing with the next one. B to the 9th, B to the 7th. I say, okay, 9 plus 7 is 16. So let's try this. 2 to the 9th, 2 to the 7th. Is that... So let me write it just like that. I'm going to copy it just like that. 2 to the 9th, parentheses and everything. And then this is to the 7th power above that. Oh my gosh, that's a big number. So that's probably not the same thing as adding them. No. What if I multiplied them? That's 63. What's 2 to the 63rd? Oh my gosh, it's a humongous scientific notation number, but they match. Which means I can come over here, pat myself on the back again, and say this is B to the 9 times 7, which is 63. So make sure you use your numbers, your letters, as always, as you're following along at home or at school, wherever you're watching this. Or maybe you're at a restaurant. Maybe you're at Wendy's getting that 4 for 4. Shout out Wendy's, always. Because now I know, once I have numbers, I know my patterns. Well, this is just like the one we just did up here. So I know 3 to the 2nd power raised to the 2nd power is the same thing as 3 raised to the 2 times 2 power. 2 times 2 is 4. So it's 81. And I could check that. I could check that by saying, what's 3 to the 2nd? To the 2nd. And my calculator smartly will tell me the same answer of 81. And that's what we're going to plug in. Anytime we have numbers, we will plug in a number. All right, similarly, for the next problem, I remember from number 1 that if I have the same base here, 6 to the 5th times 6 to the 3rd, that the base stays the same. It's still 6, but it's 6 raised to the 5 plus 3 power. And 5 plus 3 is 8. And once again, I can check that here. I can prove this to you by typing in 6 to the 5th times 6 to the 3rd. It's a very long answer, but it is the answer. 1, 6, 7, 9, 6, 1, 6. All right. Halfway done. Number 5, same thing, but notice now we have parentheses around our base. When that is the case, we must type it in with those parentheses. If I forget the parentheses and have an even exponent, which is exactly what I have here, I will get it wrong because PEMDAS will do my exponents before my multiplication, and we will be not in good spots. All right. That is the same thing as, of course, 5 plus 5, which is why it really helps, especially for timing. It was much easier to just type this in than it was to type this whole thing in above. 59049. The next one has 3 different base 9s, which is fine. We still just need to add up our exponents. 0 plus 4 minus 2, or you could put plus -2, your call. Either way, you're going to get 2. So for me, that's just 9 to the 2nd power. All I'm doing is I keep my base 9, and I just add my exponents, 81. Now, this is the point in our assignment where you could get, I'm going to call it unlucky. And depending on the problem you have, you are staring at a decimal right now. Well, you'll notice we don't want decimals. We want an exact simplified answer that's often rounded with a decimal. So let's redo our question. I want to try and find one until I get one that you might be staring at your screen. Not that one. That one's just 9. Bear with me as I redo this a couple times. You could fast forward if you've already done it. If you're still stuck on number 6 because of your crazy exponent, this is just 49. Okay. Show me a negative exponent. Nope. This is what's 1,000. All right. I'll do this a couple more times, and then if I don't get one, I'll just make one up. But you can see how it's like Dylan flexing right now, just getting these problems right immediately. Okay, this is going to be 100. I will just do one more. All right, I'm going to make one up. Oh, actually, I didn't technically get to redo that one. Last chance. Show me a negative exponent. Oh, it's so close. It's an exponent of 1 again. I mean, in theory, you could always press redo and get an easier one, too. If there's one thing I'm showing you right now, it's that. But no, let's think about it. Let's say we have 5 to the -3rd times 5 to the -1st times 5 to the 0. If you have something like this, let's make this easier to see. You add up your little numbers here, and you get 5 to the -3 and -1 make -4, and 0 still make -4. So you have 5 to the -4th power, which you're going to be seeing as this decimal. If you enter the decimal, there's a chance that you're wrong. So I want to show you how to write it in as a fraction to get the exact answer so you'll get it right. If you have a whole number to a negative power, what that means, the negative power says to get rid of it, and we always want to get rid of our negative exponents, you have to flip your whole thing. Well, right now, our whole thing is just a number, but we can remember that any number is always a fraction if we put it over 1. So that if I flip it upside down, take the reciprocal in some way, the 1 ends up on top, and my negative goes away. And then I could type in my calculator, what's 5 to the 4th power? And it'll say, let's see here, 5, 25, 125, 625. So then my answer is going to be 1 over 625. So you basically type in whatever your problem is with the negative exponent removed. So like 5 to the +4th, put a fraction with a 1 on top, and whatever you get's on bottom. And we're going to have a chance to do this. Don't worry if you've lucked out on number 6. We're going to do this on number 8. But only after I teach you a little mini lesson on the 0th power. The 0th power. Any number to the 0 power is always the same number. Now, people often say 0. Well, that's true for any number times 0. Or they'll say itself. Well, that's true for any number minus or plus 0. But any number to the 0 power is something different. And I'm going to try and show you real quick why this is true. So math is all about patterns. My favorite mathematical lessons to teach and to do personally are the ones that are basically just utilizing patterns. Patterns are fun to me. This is all about patterns for this assignment. So I'm going to have the 0 power here, the first power here, the second power here, the third power here, the negative first power here, the negative second power here. Oh, I guess we can just ignore the third power for now. Let's get a little bit of a thicker eraser to help erase that. Okay. So we're going to talk about patterns. If I have my numbers 1, 2, and 3, I know that 1 to the first power is 1, 1 to the second power is 1, and they're always just 1. 2 to the first power is 2. 2 squared is 4. I know I just said that if you have negative exponents, you make a fraction with a 1 on top, and whatever you get over here, you just copy on the bottom. So x to the second power is 4, so x to the negative second power is 1 over 4. X to the first power with 2 to the first power is 2, so 2 to the negative first power is 1 over 2. And same thing with the 3's. We have 3 and 9, so this is 1 over 3. Whoops, wrong spot. 1 over 3 and 1 over 9. Now you'll notice the pattern I'm talking about here. Anytime we're going from left to right, you're just multiplying by your base. You're multiplying by x. So if it's 3, I'm multiplying by 3 each time. If it's 2's, I'm multiplying by 2 each time. Similarly, backwards has the opposite pattern. Each time you are dividing by x. Well, the only number in the middle that will keep the pattern working for every single number, if I keep multiplying by 2's for the 2, well, either 1/2 times 2 or 2 divided by 2 will both give you 1. 3 times a third and 3 divided by 3 will each give you 1. And sure enough, it's the same logic for 4, 5, 6, 7, all the way up for an infinite amount of numbers. No matter what you have to the 0 power, it will always, 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 always be 1, closing in 3, 2, 1, 0. So that means that I could type literally any number. It could, oh gosh, the negative signs are screwing me up here. Any number, and then I put to the 0 power. It doesn't matter what that number is. It's always going to give you 1. It doesn't matter if it's a letter to the 0 power number. Anything to the 0 power is always 1. And we will finish out with this negative exponent as I previewed before. No matter whether you escaped it or not on number 6, you have it right now. Some number to the negative power that if you type in your Desmos calculator, shift 6, negative 4, you get a decimal, and it might be an ugly decimal. We got to get rid of that decimal. So what we do is we type in our problem without the negative in it. So 256, and we do exactly what I just said before. We put a fraction with a 1 on top, and we put 256 on the bottom. And that's it. Any whole number to a negative power, that's all you have to do. And I will show you next assignment with division property of exponents what to do when you have a whole fraction raised to a negative power, among other things. So, very exciting times. Thank you for paying attention. Hopefully you got all of them right, including the negative exponent ones. Best wishes on your day. Until next time, this has been Class Away from Class. Much love from your teacher, Dylan.